Hello all, welcome to the day 67 of the daily case study series for CBSE grade 12. The question goes like this. A relation R on a set is said to be an equivalence relation on A if it is reflexive, symmetric and transitive. R will become reflexive if A, comma A exists in R for every A in A. R will become symmetric if A, comma B exists in R, then B, comma A is also there in R. R will become transitive if A, comma B in R and B, comma C in R, then A, comma C is also present in R. Question 1. If the relation R defined on the set A, then define if R is reflexive, symmetric or transitive. For R to be reflexive, 1, 1, 2, 2, 3, 3 should be there in R. So it is there. Therefore, R is reflexive. For 1, 2 in R, we don't see a 2, 1 in R. Therefore, R is not symmetric. For 2, 3 in R and 3, 1 in R, there is no 2, 1 in R. Therefore, R is not transitive. Putting the results together, R is only reflexive. It is neither symmetric nor transitive. Question number 2. If the relation R defined on the set A, then check whether R is reflexive, symmetric or transitive. In R we don't find 1, 1. 1, 1 is not in R. That's enough to prove that it is not reflexive. We don't even have to check if 2, 2 and 3, 3 is there. So R is not reflexive. For 1, 2 in R, 2, 1 is also there in R. For 1, 3 in R, 3, 1 is also there in R. Therefore, R is symmetric. For 1, 2 in R and 2, 1 in R, there is no 1, 1 in R. Therefore, R is not transitive. Putting it together, R is only symmetric. It is neither reflexive nor transitive. Question 3. If the relation R on set n, that is set of natural numbers, defined by R is equal to set of ordered pairs x, y such that y is equal to x plus 5 and x should be less than 4. Then check whether R is reflexive, symmetric or transitive. Now let's write R as a set of ordered pairs. Here x should be less than 4. That means x can take 1, 2 and 3 alone. Suppose if we take 1, y will become 6. Suppose we take 2 for x, y becomes 7. Suppose we take 3 for x, y becomes 8. So these are the three ordered pairs. R is defined on set n. 1, 1, 2, 2, etc. are not there in R. Therefore, R is not reflexive. For 1, 6 in R, we don't see a 6, 1 in R. Therefore, R is not symmetric. Now let's check whether R is transitive. For 1, 6 in R, there is no ordered pair such that 6 is the first element. that is 6, z does not belong to R. Same is the case with 2, 7 and 3, 8. Therefore, R is transitive. Putting the results together, R is only transitive. It is neither reflexive nor symmetric. Question 4. If the relation R on the set A defined by R, then describe R. A is given as a set of 1, 2, 3 till 14, and R is defined as a set of all ordered pairs such that 3x minus y is equal to 0, and x comma y belongs to A. Let's frame the elements for R based on the given definition. Definition is 3x minus y is equal to 0. Suppose if we take 1 for x, so it becomes 3 times x minus, to make this expression 0, we have to take y as 3. So 1 comma 3 is one ordered pair. Suppose if we take 2 for x, 3x is equal to 6. Y must take 6 to make this expression true. So the ordered pair is 2 comma 6. Suppose we take 3 for x, 3x becomes 9. So y should take 9 to make the expression true. Suppose if we take 4 for x, 3x will become 12. So y has to be 12 to make the expression true. Suppose we take 5 for x, 3x is 15. So y should take 15. This ordered pair is not possible at all because A is running from 1 to 14 only. So we have to stop till 4, 12. So R is 1, 3, 2, 6, 3, 9, 4, 12. Now we have to see if this R is reflexive, symmetric and transitive. There is no 1, 1 in this. Therefore, R is not reflexive. For 1, 3 in R, there is no 3, 1 in R. Therefore, R is not symmetric. For 1, 3 in R and 3, 9 in R, we don't see a 1, 9 in R. Therefore, R is not transitive. Putting the results together, R is not reflexive, not symmetric, and not transitive. If you found this video helpful, don't forget to like, share, and subscribe to my channel, Math with Meenakshi, for more smart learning videos. See you all with another case study question tomorrow.